Hey, before I kick this off, I just want to say this is going to be a long video, so make sure you check out the table of contents. Plus, this was also recorded over about a week, so there's going to be little inconsistencies. My shirt's going to change. I'm going to have shaven face, not shaven, so just bear with me, and I hope you enjoy. Hey, folks, welcome back. So I was cruising around the internet and just looking for things that are going on in the hobby, and I came across a really neat design by Dave C again. If you don't know who Dave C is, he is the kind of the brainchild behind basically the whole 4-inch long range movement. I absolutely love flying these things. They are a ton of fun. They're quiet. They're not threatening. Long range is kind of interesting. It's not like heart pumping exhilaration, kind of like racing and freestyle, but it does fill a certain niche that I have for flying, and I really enjoy this. So I was poking around the internet and I saw that Dave C had a new concept for a long range build. This time it's a 3-inch. But the neat thing about it that makes it something I'm interested in, and if you followed my channel for a while, you know that unique frames kind of really catch my interest and are something I'll look at. Uh, his new design runs off one of these. This is it, just one 18650 lithium ion cell. And his creation is called the Nano Long Range. And it looks something like this. Well, this is my take on what it looks like. This is his design. It's free to download on Thingiverse. It's 3D printed. This is printed out of PETG. He recommends PLA, but well, let's face it, PETG is better, right? Am I right? Am I wrong? What do you think? Let me know now. This was a very fun build. It's a pretty fun quad to fly. It's very interesting. Just the fact you can go out and just snap in a 18650 cell and off you go. I've been able to get anywhere from 10 to 15 minutes of flight time depending on what cell you use. There's plenty of different cells out there and they all offer different properties. I recently made a video on how I built a 4S lithium ion battery out of individual 18650s. Check out that video in the description below. It'll kind of go through the differences in the cells when you're talking capacity versus discharge versus cost. Check that out and you'll kind of get an idea of what cell I'm probably going to go with. All right, so let's hit the bench and I'll show you how we end up with one of these. So obviously we're going to use the Dave C frame. So this is available on Thingiverse. I'll put the link down in the video description. So it's a two-piece design, one top plate and then one lower kind of electronics plate. And they kind of go together like to make the complete frame. On top here, I have just one of these cheapo 18650 lithium ion battery holders. I had to go and cut the bottom out and kind of widen her out. I soldered some wires onto it and just kind of used some E6000 to hold it in place. Ideally, once this is all together, I'm going to be able to access my USB port for my flight controller through the top here. That's why the big cutout. I didn't record that process because it's literally just Dremel, cut, and glue. And your setup may vary because of what components you use. The flight controller is going to be the HGLRC Zeus AIO. It's also the same one he specs on the Thingiverse listing. It's actually a pretty neat looking flight controller. It's pretty well full featured. This is going to end up screwing into the top plate like so. As you can see, there's our USB port that I tested. I can actually get one of my USB cables down inside of there. It's something you got to consider is how much space you're going to have. So that's the frame. That's the flight controller. As far as the motors go, I'm going to be using these. These are the FPV Cycle 13 millimeter toothpick motors. 11,250 kV. The motor wire is going to be too short, and I already know that. I'm going to have to lengthen them out. I might use some race wire. I'm not really sure yet. These wires are definitely going to be too short. The camera is going to be the Caddx Ant. This thing is probably the smallest camera I've seen that actually has like actual mounting holes on it. Okay, video quality, not the greatest, not the worst, but we're looking for small and light. The camera is the Caddx Ant. And as far as the VTX goes, I'm just going to use a eSheen
Nano VTX I have laying around. Props are going to be the GemFan 3018. And a few other things you're going to need is you're going to need a 5-volt step-up converter. And they do recommend a LC filter because there does end up being an awful lot of noise in the video. So the step-up converter is basically just to power the VTX. If you're going to go with a lithium polymer battery, you probably can get away without this by just using a camera that'll power the VTX or a VTX that runs on that low voltage. Unfortunately, with lithium ion, most of these most things that have a BEC built into them only go down to about 3.4 volts before they shut off. With lithium ion, we're going to be looking to get down to like 2.5 volts maybe. So if your power conversion source is cutoff is higher than whatever our minimum voltage is out of 18650, it's not going to work. So that's why we need the 5-volt step-up converter. This is a Pololu. Again, I'll put links to all this stuff down there, video description. All right, let's go ahead and get started building this thing. So like I said, start off with the frame. This is just glued on with E6000. Make sure you take note of where your polarity is, positive, negative. Doesn't really matter. You just need to make sure you put the battery in there the correct direction. So that is going to go like that. There are some pieces of hardware, screws, things like that you're going to need. This flight controller comes with the little bobbins.
So this flight controller comes with the little bobbins, but does not come with any mounting hardware. I just found some coarse thread hardware that just barely stick out past the bobbins. That's going to be more than enough to engage with the plastic on this frame.
The flight control is kind of nice because everything is broken out on both sides of the board. Actually, there's more things broken out on the underside, or what's going to be the underside, than on the top side. So this is going to work out just fine. That's going to go one there. And there we go. 1, 2, 3, and 4. And we don't want to tighten these down too much. We just want the screw heads to just barely protrude through the plastic. And I'm just kind of gauging with my finger. There you go. So there's our flight controller installed. I could still get down there and access the USB port with my normal USB cable. A little bit of grinding, cutting, get you down in there. So that's that. The wiring is going to be a little interesting just because we do have to put that back in there.
So he's included a really nice wiring diagram of how to wire this whole setup up. It's pretty straightforward. I would draw one, but why reinvent the wheel? We've got our battery holder. It's going to go positive, negative, and make sure we install the cap that came with that flight controller. From there, that positive wire is going to go into the step-up converter. We have our ground to the LC filter to the VTX, and we're going to pick up a ground on the AIO. Doesn't really matter what ground, just any ground. And there's our stepped up 5 volts through the LC filter to the VTX.
Just going to use my trusty bench iron here, or my trusty portable soldering iron here. This is the Sequire something, I don't know, links, description, yeah. No, just a normal strip and tin routine. Nothing fancy. I haven't used a lot of HGLRC electronics in a while. There we go, power and ground. So this thing should power up by plunking a battery in there. This is just a VTC4, nothing special. There we go. Powers up. No tones because we need the motors installed for tones. So don't worry too much about that. So that's power and ground. We should probably focus on getting these motors installed somehow. The motor screws that come with these motors are not going to work out for you. They're going to be too short. You want to try to find some 5mm long screws. And just don't over tighten these things. Crack them. All right. There's one motor. Yep, we're definitely going to need to extend these wires. I would say this is not a beginner build. All right, now I'm just going to speed through this.
So with all 4 motors installed, it became very obvious that the motor wires are far too short. I was thinking about using race wire, but I don't want to clip any length off the wires that I already have. I don't plan on leaving this quad set up this way, and I kind of want to be able to reclaim these motors for a different build down the road if I decide to do that. So we're going to go with the old lengthen the wire method. So clip, strip, tin, solder, heat shrink, all 12 wires. It's a long process. It's boring, tedious, and well, it's just plain no fun. It's a lot of repetition, but in the end, we'll get what we need. And I'm not going to bore you guys with the whole process. I'm just going to go through it. You guys know how this goes. And if you have any questions, put them in the comment section below. I'd be more than happy to answer any questions you have about this. And if you're looking to purchase any parts for your build, go to tweetfpb.com, click those affiliate links, and give back a little bit. And if you really want to support me, head over to Patreon. Don't forget to like and subscribe, guys. All right, after some solder, some heat shrink, and some tape, there we go. Nice little setup connected to the AIO.
So here we go. We've got the eSheen Nano VTX. This is not the Pro model. This is the one that doesn't have the microphone because I don't care about microphones. Power ground, tramp, and video in. And I know this is going to go on the back of the quad, so I'm just going to go ahead and stick it in place now and then kind of regret my decisions and have to work around it for the rest of the build. I'm just going to put it right on in there. There we go. Make sure all that glue and stuff sticks out through the bottom so it sticks to all the grass and everything that gets on it. All right, and I just left a big old bunch of wires sticking out because why not, right? Moving on to the camera, this is the Caddx Ant. Luckily, it comes with some hardware. Save this kind of stuff for later, you know? You never know when you're gonna need it.
So be sure to hook up your wires before you install the camera. There's not a lot of clearance behind it once you get it installed. And use the shortest screws that came with the Caddx Ant.
So I'm finding that the solder mask really kind of sucks on this HGLRC board. I don't know if I'd really recommend this flight controller to anybody. Seems like it kind of wants to burn off pretty easily. There's our camera wires. They're a little tighter than I would like, but you know, they're on there. Not too bad looking. Sort of would like a little bit more length, but that'll work for this build. Oh, okay, we can move on to the VTX now. Just tin up some pads. So that's going to be our smart audio, our video out, and ground. We're not picking up the 5 volts here because we're going to have to use that step-up converter to get our 5 volts.
So this tiny little Polulu step-up converter is going to convert our 1S voltage to a consistent 5 volts, and it's going to work right up down to about 2.5 volts. So at that point, below 2.5 volts on that one lithium-ion cell, we'll eventually lose our VTX.
The biggest solder pads on the whole quad. Voltage out, ground, and voltage in. I'm going to go and slap some heat shrink on that guy. And I actually decided to just go with Kapton tape in this case. Super light, and it'll be perfectly fine for what we're trying to do. All right, so the next thing in this build is going to be this LC filter. This should help us achieve some cleaner video, because this 1S setup is going to be kind of noisy. So I'm going to wire that in line. There we go. So we've got our voltage out and our ground out going into our LC filter. Out of here, we're going to go into our VTX, and this we're going to have to use to pick up our main power. Knew I was going to regret sticking that VTX down early. There we go. I'm just going to wrap that with some Kapton tape as well. There we go. All right, so now we have our grounding wire to go to the flight controller, our LC filter, our step-up converter, and our VTX.
Here I'm just sticking the ground wire to any ground on the flight controller. This goes to that LC filter.
Get our video wire.
And this blue wire is for VTX audio switching. In this case, we're going to be using the Tramp protocol.
And now we just got to tag our power wire into power wire there. There we go. Just most of our electronics, minus the receiver. It's all gonna get stuffed inside of there like this. Now we just have to wire up our receiver.
One thing I do really like about this flight controller is it does have the power ground, the TX and RX pads broken out, specifically for Crossfire or Tracer for that matter. Pretty large pads, pretty easy to get to. They're intended to be pinned in place, but I'm not going to do pins for this setup. I'm just going to do wires since we're kind of short on space underneath the flight controller. So here it is, all buttoned up. I just put the Crossfire antenna just along the bottom of it, just kind of haphazardly taped in place. My only goal is to really just keep it out of the props. I know this isn't optimal for range, but then again, we are only on like 300 milliwatts with a little whip antenna, so range isn't going to be, receiver range isn't going to be the limiting factor on this guy at all, but it does fit together quite nicely. You do kind of have to manage your wires around this little plastic opening, but fortunately, if your wires are a little too tight, it's plastic. You just kind of trim it to fit.
All right, folks, here we go. 4, 3, 2, 1. Oh, no smoke. Got the tones. Should be good. All right. Let's hope the Betaflight works. It was kind of touch and go with those solder points for the USB there.
Since this flight controller is installed upside down and backwards, we're going to need to readjust the alignment of the gyro. You're going to want to go to the configuration page and do a 0-degree flip.
All right. Nose down. To the left, down. And spin it to the left around the yaw axis. There we go. Perfect. So that is a configuration. It's a 0-degree flip. All right. Now we'll calibrate the accelerometer while we're here. There we go. ports.
On the ports page, you're going to want to have UART2 serial RX enabled as a receiver, and soft serial 1 will be tramp for this setup. This board doesn't have enough hardware UARTs on it, and we definitely do need the soft serial for the VTX audio switching. Make sure we reverse props and then come down here and select Crossfire. Make sure we enable telemetry and our motor beeper. If we have the receiver bound, we see that it's actually connected to the quad, but the mapping's wrong. For me, it's TAER 1234. This is how I set up my modes. Everybody's different, but this is how I did it. Flip over after crash probably isn't going to work well with this quad, but I enable it anyways in case I land like on a roof or something where I might actually have a chance of getting out of my situation. As far as setting up VTX tables goes, download the tramp JSON file from the link in the above box, and then just come through and customize the power outputs for your VTX. I only have 4 levels, so I just adjust it there and hit save. So for testing the motors, the issue I'm going to run into is I can't apply power to the flight controller and have the USB connected at the same time. So I had to piggyback a 18650 power supply to the cradle.
Motor mapping, motor remapping. Yeah, I know it's gonna be way off. So we got that.
Telemetry recovered.
Yeah. Betaflight is up and running. Take my battery.
I'm not really going to show how to do the resource reassignment for the motors. There's plenty of videos on how to do that. Here's just the permutations that I had for this setup. And if you're doing the same thing I'm doing, then it should be the same for you as well. So to make a long story short, the motors certainly are not mapped properly. Here is the permutations that I needed to do the proper mapping. Resource motor 1, B06, resource motor 2, B07, resource motor 3, B04, resource motor 4, B05. Be sure to save that.
Nope, spin the wrong direction, but that's okay.
So I do have a few motors that are spinning the wrong direction. Pretty easy fix. We're going to go to Chrome and use BL Heli. It's a Chrome plugin. Make sure you close Betaflight before you connect to it. Read setup, and we're going to reverse motor 1 and motor 3 and hit right. And after that, we can go and check, make sure we have the latest version of BL Heli. I have 16.7, and it looks like 16.7 is the latest official release. There is a beta, and I'm just not going to mess with it. Back to Betaflight.
So these are all supposed to be spinning props out, so that's good. 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 And good.
And just a quick check of the VTX. This camera actually is pretty bright. It looks good in this dark room. Kind of impressed.
All right, so this is the Nano long range 3-inch. There we go. I got the camera set up at like about a 45-degree angle, so it's not going to be the slowest flying. And my goggles fog on pretty bad. Shut up, cat. And I didn't put a directional patch on either. Really didn't think this through. So let's just go ahead and cruise around and see what kind of flight time we get. This is going to be on the Molicel P26A. These are 2600 milliamp lithium ion 18650s. Well, 18650 since it's literally only one of them. Wow, my God, it was fucking bad. Just got back from a run, so I'm kind of hot and sweaty. And the orcas absolutely suck at defogging. I like everything else about them, but this aspect is pretty garbage. What the heck that noise is. Is the fan even on? And that's the other thing, is you never know if the fan's actually on or not. Makes two little beeps. Very hard to distinguish between the two. It would almost be nice if they put a maybe on-screen display. Fan on, fan off. Or should just put a good fan in it. I'm not going to do any acro flippy doos. I know it'll do it. I just want to see what kind of flight time we can get if we're just cruising, like cruise out, cruise back type of flight regime. There's a very mild tune on it. Looks like my goggles are starting to unfog. Not fast enough, though. A lot of throttle resolution. It's not going to be a lot of punch out. There we go. I can almost see out of my left eye now. So as far as the power goes, it's like flying a like an 85 millimeter ducted whoop. That's what the power feels like, just without the noise. Doesn't seem to be affected too badly by the wind, but I can feel a little bit of bobble here and there when the wind blows. So I'm going to shut up and just let her run. That is the first time I've ever had my TBS Fusion roll. Mark it in the books. It does roll. That is the first time ever. So about 2.5 volts, I'm going to lose my VTX. It should still keep flying though. 16 minutes at 2.6 volts. 2.5, 2.4. And I'm going to lose my VTX right about there. "16 minutes and 32 seconds, and it bounced back up to 3 volts. That's not bad. Not bad at all.
Well, that was pretty darn impressive. Out of one of these little 18650s, granted, these are some pretty good 18650s, and your results will definitely vary on the type and quality of cell that you purchase for this little build, but 15 and a half minutes is pretty darn good. I know the video showed 16, but that was on time, not arm time. I set up the OSD wrong, but I'm pretty impressed. I probably could have squeezed a little bit more time out of it. If I could find a way to get over that 2.5 volt cutoff threshold for the VTX, probably could fly just a little bit longer. But here's some numbers for you. So this board does not have a built-in current sensor, but I have a analyzer for my 18650s that tells me how much I put back into it. I put 2,457 milliamps back into this cell right here. And I did a test on it to figure out what its actual rated capacity is. And the actual rated capacity is 2,651 milliamps. That's about 93, 94% of the available amps were drawn out of this cell, provided my equipment is at least somewhat accurate. Which brings me to another point is if you're going to be doing this kind of stuff, you're going to be building 18650 packs, you're going to be flying these things with 18650s, you really need to have a way to analyze the quality of your cell, internal resistance and capacity. I highly recommend something like this. This is the Litakala Lee 500. I'll put a link in the video description. This is an extremely nice tool to have. It will analyze, charge your 18650s and I think a few other types of cells, but we're not too concerned about that. But I do definitely highly recommend that you pick one of these up, even if you don't really plan on doing in-depth things with 18650s. If you do charge 18650s on a fairly normal basis, I do recommend this charger. Very nice charger. So overall, what do I think of this little project here? This is not a beginner job. This is a very advanced build. Very small solder points, very questionable quality electronics just because everything has to be packed in so small and at a price point. You got to do all the Betaflight hacks. You have to do the, obviously we have to do VTX tables. You're going to have to do board alignment. You're going to have to do resource reassignment. You're going to have to do reversing of motors. This has it all. Like, this is advanced. If you can do this, you can build anything. As far as the electronics go, the Zeus AIO, it's probably the best option out there. The only other one I saw was an iFlight Sussex flight controller that comes with a VTX. I didn't see any good pinouts of how you could use it without another VTX. I'm sure you can. You can do just about anything. That one does have a current sensor. This HDLRC Zeus AIO that was spec'd out by Dave C seems to be okay. The solder mask is kind of meh. The components are very small, very tight together. It's very easy to accidentally bridge some solder points. You got to be very careful with this. Invest in a very good jeweler's loop because that is going to pay off very quickly. These FEV cycle 11,250 kV motors are very nice for this build, and they will serve well in future builds. The Cax Ant, not the greatest camera in the world, but it's small, light, and it gets the job done. Lots of noise in it, but that's going to be a side effect of driving this little cell so low, and it's a very noisy setup. I did have a lot of fun making this thing, and I do recommend if you are at least curious about it, go ahead and do it. 3D printing is cheap if you got a 3D printer, or if you're looking for a 3D printer, the best 3D printer you can have is the one your buddy owns. Trust me on this one. Have somebody kick out a frame for you and give it a shot. I am going to try to design my own carbon frame kind of for this setup. I think it'd be kind of an interesting little job. We'll see if I ever do it. I don't know. That takes a lot of time, and that's one of those things I just don't have a whole lot of lately. All right, folks. I hope you enjoyed this. I certainly did. If you're interested in any of the parts I put in this, links in the video description. Same thing for the links to the STL files from Dave C. I know he has more plans with this since he's partnered up with HDLRC. He'll probably have something coming out under the Recon brand because that is like the HDLRC in-house long-range branding for Dave C. It's awesome to see somebody that is in this community that's putting so much effort into it actually getting recognized and sponsored, and a company letting him kind of just run with his ideas, which two big thumbs up for that. All right, folks, thanks for stopping by. Thanks for checking us out. If you have any questions, please put them in the comments below. If you're curious about anything I'm doing, tweetfpv.com. Click the links in there if you want to support me. There's links for Patreon, all the social medias, and then some of the few affiliated vendors I have going on over there. All right, folks, stay safe, and we'll see you next time.